Hello everyone and welcome to the BrainOmega channel. Have you ever wished you had a personal assistant to take notes during your meetings? Well, today we're going to build one. You can find the complete code and examples on our GitHub page. Just check the link in the video description. In this step-by-step tutorial, we'll create a complete meeting minutes generator using Python. This powerful tool will take any meeting audio, transcribe it using OpenAI's Whisper, generate professional structured meeting minutes with a Llama 3.1 model, and finally, give us a downloadable PDF of the results. We'll cover everything from setting up the models to building the user interface. Let's dive in and build our very own AI meeting assistant. So, what's the big picture? Our application automates the entire process of creating meeting minutes. It starts when a user uploads an MP3 audio file of their meeting. This file is first sent to OpenAI's Whisper API, which is incredibly accurate at transcribing speech to text. Once we have the raw transcript, we send it to a Llama 3.1 model. This is where the real magic happens. We'll use a carefully crafted prompt to instruct the Llama model to act as a professional minute taker, organizing the messy transcript into a structured document with a summary, key discussion points, and clear action items. Finally, to make the output easy to share and store, our script will convert these generated minutes into a PDF file that the user can download directly. We'll use the Gradio library to create a simple and clean web interface for the whole process. Let's start with the code in meetingminutesgenerator.py. The init method is where we set everything up. First, we load our OpenAI API key from environment variables and define the names of the models we'll be using. Whisper 1 for transcription and Meta Llama 3.18b instruct for generating the minutes. Now, here's a crucial part for making this run on consumer hardware. We're using the BitsAndBytes library to load the Llama model with 4-bit quantization. This dramatically reduces the model's memory footprint, allowing us to run this powerful 8 billion parameter model without needing a top-of-the-line GPU. We define the quantization configuration and then pass it to the from pre-trained method when loading our model. This is a key optimization for making large models accessible. Next up is the transcribe audio method. This function is straightforward but powerful. Its only job is to take the file path of our meeting recording and get it transcribed. We use a simple try except block for error handling. Inside the try block, we open the audio file in binary read mode. Then we make a call to the OpenAI Python client, specifically the OpenAI.audio.transcribe function. We pass it the model name we defined earlier, Whisper1, and the audio file itself. We also specify that we want the response format to be simple text. The API handles all the complex speech-to-text processing, and what we get back is a single string containing the full transcription of the meeting. This is the core of our application's intelligence, the generate minutes method. The magic here is all in the prompt engineering. We create two main pieces of text to guide the Llama model. First, a system message. This sets the persona for the AI. We tell it, you are a professional meeting minutes writer, and we give it very specific instructions on the format we want. A summary, discussion points, takeaways, and action items, all in Markdown. Second, we create a user prompt where we provide the raw transcript we got from Whisper. We combine these into a messages list, which is the standard format for interacting with instruction-tuned models. We then use our tokenizer to prepare these messages, generate a response from the model, and finally do a little bit of string cleaning to remove any special tokens from the model's output, leaving us with a clean, well-formatted Markdown document. Once we have our beautifully formatted Markdown text, we need a way to present it professionally. That's where the generate PDF method comes in. This function uses the fpdf library, a simple and effective tool for creating PDFs in Python. We initialize a new PDF object, add a page, and set a standard font like Arial. The key component here is the multi-cell function. We loop through each line of our generated minutes and add it to the PDF using multi-cell. This function is great because it automatically handles text wrapping, so we don't have to worry about lines running off the page. Finally, we generate a unique file name using Python's UID library to avoid overwriting files, save the PDF, and return the file path. The process upload function is the main orchestrator of our backend logic. It's a Python generator function, which means it can yield values back to the user interface incrementally, allowing us to show real-time progress updates. First, it performs some basic input validation to make sure a valid MP3 file was uploaded. Then, it calls the methods we've already discussed in sequence. It calls transcribe audio to get the transcript, yielding a status update to the UI. If that's successful, it calls generate minutes to create the structured text, again yielding an update. Finally, it calls generate PDF to create the downloadable file and yields the final results, the markdown text, and the path to the newly created PDF file. This function neatly ties our entire pipeline together. Now, let's look at interface.py. A powerful backend isn't very useful without a user-friendly way to interact with it, and the Gradio library makes this incredibly easy. We define a launch interface function. Inside it, we create a gr.blocks layout, which gives us full control over the UI's structure. We add some titles using gr markdown. Then we define our core components: an audio input widget for uploading the MP3, a markdown output component to display the generated minutes, a file output component to provide the download link for the PDF, and a button to start the process. The most important line is submit button click. This single line connects our UI to our backend. We tell it that when the button is clicked, it should call the generator.process upload function, using the audio input as its input and sending the results to the markdown output and PDF output components. It's that simple to wire everything up. Last but not least, we have the main.py file. This script is as simple as it gets, and it has one job: to start our application. It imports the launch interface function we just created in our interface.py file. Then, inside the standard if name equals main block, it calls this function. This is the command that initializes our meeting minutes generator, builds the Gradio UI, and starts the local web server, making our application accessible in a web browser. To run our entire project, all we need to do is execute this one file. So, let's recap what we've built today. We've created a fully functional AI meeting assistant. It uses Whisper for highly accurate transcription, a quantized Llama 3.1 model with sophisticated prompt engineering to generate professional notes, and a PDF generator for a polished final output. And we wrapped it all in a simple interactive web application using Gradio. This project is a fantastic starting point. You could extend it by adding support for more audio formats, integrating speaker diarization to identify who said what, or swapping out the Llama model to experiment with other powerful language models. I hope this tutorial has been a valuable look into how different AI tools can be combined to create incredibly useful applications. Thank you so much for watching. If you found this helpful, please like, subscribe, and share. See you in the next one.